Yeah, I wanted to talk a little bit about what I was doing here and the progress that we made. So this is the unit assembled. I got the motor in the top. That's the adjustment for it. And I got these pieces reamed out. They fit on there real good. This is not the one that goes there, but they're all the same. So I ended up getting this reamer. Got it from Travers, and it's what size was that? Let me find it on my chart. Okay, so 196.9 is the shaft size, and that was a 197.5. Like I said, I had a 198, and that would have been too sloppy. In fact, this one's a couple tenths, could be a couple tenths smaller, but then you get into your specialty reamers, and but anyway, this one works. So I want to talk about the air bearing that I have on here. So let me put you up here. Now these holes are for these for countersink, and these countersunk screws. They all go in here, and that's what holds this thing down. But I'll take them off. So let me show you what this thing looks like when it's together. So this is the belt. I got a couple of pins that go in here. Got some bearings. Then the belt. And that's essentially what it looks like. The motor rotates its belt. Then the gear fits on here. Like that. And the whole thing rotates. It's slipping a little bit here because there's a lot of tension on here. But that's where the air bearing comes in. See, right now it's basically dry. There's no kind of lubricant or anything on here. So it's, the belt is rubbing on this surface, and there's a lot of resistance there because this piece of rubber is riding on that plastic. And that happens everywhere. This piece of rubber, no matter if you're using metal or plastic or glass or anything, it just doesn't like to rub on anything. But that's basically what it looks like. And what happens here is that air's going to come in through this fitting. I'll take that off so you can see it. I already tried this, and it works, but it's, I was expecting a little bit better. But of course, it's the first time. So I got this fitting in here. One of those push type connectors, so the tube comes in here. Let me put this back on. This is the block that's going to mount it to the frame. And I keep these on here because it keeps this thing from rolling around. It's like a little ball. And I got to keep them loose, because what happened was that this piece of stock was a little bit undersized, and if you tighten them down too tight, it hits against the outer part of this ring. So I have to keep them a little bit loose. Now what I did was I made up this little spacer that goes in there, because what happens here is that this, let me show you. This block is supposed to be really thick, and the idea behind this block is to rotate this unit. And that's what this square hole is for, is to act like a pin and help rotate this unit. But because this block would have to be another 3/8 thicker, that I really didn't see any point in doing that. So this is what it's supposed to look like if it was all one piece. This square piece fits into that square piece, and that helps rotate it. And this, I added 60 thousandths here for more clearance. But this is just something I made after. Okay, now that's tightened down all the way. See how much more room I have here versus this side, which is, there's really nothing there because it needs to be spaced out to let this rotate. So I could take that 60 and I could knock that down to maybe 40, but I gotta have room between here and there so this piece can rotate. But anyway, so we'll talk about this this bearing. So I'll take this back off. Now the idea behind this was that in order, this belt needs to engage in this gear here. So if you go to rotate this, when it's under a lot of pressure, that belt is going to try to slip off of that gear. So that belt needs to ride in those grooves. And if it's under a lot of pressure, that belt is going to want to back off. And then you're going to get a lot of slop in there. That belt will start moving. So the idea was that air is going to be put in here, and it's going to be, and there's a ring around here, and it's going to push that belt into those grooves so it won't back off. Now the thing was that since these belts are, they're rubber and they don't like to slide on anything, I couldn't just have it slide on this surface. I have to have some way of it slipping on this surface. So I thought if I could put air in here and push it out, the air would act like a cushion and engage that belt into this ring and keep it from sliding on this surface here. So that's what I tried. And it worked to a certain degree. I got it up to 20 pounds and I couldn't get it any further than that. And it seemed to work. And what was happening was it started lifting this gear up because it was getting underneath here. And it was actually pushing the gear up. And I don't have any sealant on here, and I'll show you that. But this is oh, let me take this one out. This is what it looks like. Got the air coming in here, and it travels in this groove. There's a groove all around here. Then you got these exit ports right here. Now these little circular things are before the fact. I put these in here as an anti-rotation so that this ring wouldn't rotate. But then I put these screws in, these screw holes in here, so it wouldn't rotate anyway, so these aren't really needed. But the underside of this goes like this, and then this is the underside. This is those anti-rotation. But I got the, when I made this, I put this on the 3D printer, and I couldn't print really a passageway through here, so I had to put the passage in here and basically put the flat piece here on top to capture the air. But I put these little ports through here. See that little port? Which is how the air travels from the inside of here to the outside, through that little port. Now there's a groove in here to capture the air and kind of act like a little buffer zone. But the problem I'm having is that when this piece is attached to this piece, the air is leaking around the base of here, because this surface isn't really true and flat. I checked it. I'm getting almost 15 thousandths difference between one side and the other side. And I thought about truing it up, but then I'd have to true up this surface, and this is just basically a mock-up anyway. But if I put some sealant on here and some sealant on here, on the inside of here and on the outside of here, that'll capture that air a little bit better between these two pieces. Now I had a backup plan, and the backup plan was that if for some reason this didn't really work out, because the main problem is that the belt is made out of rubber and it won't slide on anything. So the idea was to have something on here to help it slide better. So what I did on this one was I put a little piece of tape on there, and that helps a lot. I put a little piece of tape on there, and that goes pretty good there. Of course, the more you pull on it, the more friction there's going to be. Now, if you do that with a belt that doesn't have the tape on it, you can't even make it slide. I mean, there's no tape on this one, and it just doesn't slide at all. So the idea was to have like a go-between between the belt and this piece. So this piece didn't use the air at all. It's just solid back here. There's no grooves or anything for the air to come through, because the air wouldn't be used on this piece. But what I was going to do was I was going to have a piece like this, and then the belt would be there, and there would be a backing material between the belt and this piece. And ideally a piece of plastic would work good, because plastic, it slides on that plastic really good. But the idea was to have this thing come through here. And this would ride on the back of the belt. And what was happening, or what would happen, is the belt slips along this piece and it takes this piece with it. So it rotates with the belt. And then it would go around, and instead of going around this pulley, it would go into this channel, then rotate on its own, and then get picked back up when the belt exited. Oh, there goes my bearings. So when the belt exited, it would get picked back up by the belt and continue on around here. But what would happen here, well, I 3D printed this, and it's too thick. It's not flexible enough. And it was too long, and I had to cut it to make it shorter. And of course, I can't get it back together. But I wasn't sure what size I needed here, so I had to start with a size, and then I had to make it fit and then cut it. And now this is the size that I would need, is this size right here. But I have to make it thinner. So I tried to make it thinner, and my printer wouldn't print it because it was too thin. I think this was like 30 thousandths or 40 thousandths, and I was trying to get it down to around 20 thousandths. And I was using a number 6 nozzle, and the printer wasn't printing it because it was too thin. But that's the, I mean, if I could find a piece of something that could go around there, that would work out pretty good too. See, is that it would go behind this belt, and then of course this would be a little bit further away from that pulley. It would go around that pulley, and it would come off and get picked up on this rail, come around here, then on the back side it would get picked back up by the belt, and then continue on around here. So that would act like a piece between the belt and the plastic. That's still something I'm thinking about. But that's about where we are now. But I got to get this top piece working. If I can't get this top piece working, there's really no point in doing anything else. But I think I can get it working. I printed that on the printer. I tell you, that printer, that's a marvelous little machine. Printed this too. But it's coming along. Oh, I fixed this piece. That was detached, and I put a couple screws in there, and well, let me show you what I did here. Yeah, this was if you remember, this was after it was already made. I should have incorporated it into the model, but you know, that's just like the way it is. So these two pieces of brass are used to hold this onto here. And then these two pieces are the bushings for the shafts that go through there, which is actually this shaft. This shaft actually goes onto that motor over here. This fits through that way. This is the bearing for that shaft. This one, because the motor's there. Yeah, you can see the shaft through there. I can see the... Yeah, it's that one. That goes in there. Well, it goes like this. So I'm going to incorporate this design into the next one, so I don't have to install these brass pieces. But I had to do something. I had to attach them somehow for now. But anyway, that's where we are. So, talk at you later. All right, bye.